the previous lesson, we're going to take 4 of the fertilisers, which each contain at least one of the essential elements, NP or K, and they are all soluble. And in this lesson, what we're going to do is we're going to compare each of the fertilisers to work out which has the biggest percentage composition of each essential element, NP and K. So let's calculate the percentage composition of each essential element in KNO3. First thing we have to do is we have to calculate the GFM. The first element is potassium, K. How many have I got in the formula? I've got 1 multiplied by the relative atomic mass, which is 39. 1 times 39 equals 39. Nitrogen, how many have I got in the formula? I've got 1 multiplied by the relative atomic mass, which is 14. 1 times 14 equals 14. Oxygen, how many have I got in the formula? I've got 3 multiplied by the relative atomic mass, which is 16. 3 times 16 gives 48. And when I add those up together, I get a GFM of 101 grams. Because I'm wanting to work out the percentage composition of each essential element, I'm going to be looking at potassium. And what we do is we put the total mass of potassium, which is 39, over the GFM, which is 101, multiply it by 100 to put it into a percentage, and that comes out at 38.6%. Nitrogen, the total mass of nitrogen we've got is 14 over the GFM, which is 101, multiplied by 100, and that gives me a percentage of 13.9%. When I add up those percentages, that means that the total percentage of essential element in the KNO3 is 52.5%. Let's work out the percentage composition of each essential element in potassium phosphate. Firstly, we have to work out the GFM. How many potassiums do we have in the formula? We've got 3 multiplied by the relative atomic mass, which is 39. 3 times 39 gives 117. Phosphorus, we've got 1 in the formula, times by the relative atomic mass, which is 31. 1 times 31 gives us 31. Oxygen, we've got 4. 4 times 16 gives 64, which means the GFM comes in at 212 grams. To work out the percentage composition of the potassium, we take the total potassium, which is 117, divided by the GFM, which is 212, times by 100, and that gives us a percentage of 55.1%. Phosphorus, we take 31, divided by 212, times by 100, which gives us a percentage of 14.6. When I add the total percentages up, that gives me a total of 69.7% of essential elements. So let's calculate the percentage composition of each essential element in ammonium nitrate. First thing we have to do is calculate the GFM. How many N's do we have in the formula? We've got 2 times by the relative atomic mass, which is 14. 2 times 14 gives us 28. How many hydrogens do we have? We've got 4. 4 times the relative atomic mass, which is 1. 4 times 1 equals 4. Oxygens, we've got 3. 3 times the relative atomic mass, which is 16, gives us a total of 48. And when we add those up, we get a GFM of 80 grams. To work out the percentage composition, we're only interested in the elements NP or K. The only element this contains is nitrogen, so we do the total mass of nitrogen, which is 28, over the GFM, which is 80, and times it by 100 to put it into the percentage, and that gives us a total percentage of 35% of nitrogen in ammonium nitrate. The last one, we're going to work out the percentage composition of each essential element in ammonium phosphate. First thing we have to do is work out the GFM. Be careful with this one. How many nitrogens have we got? We've got 1 inside the bracket multiplied by 3 outside the bracket, which gives us a total of 3 nitrogens, times by the relative atomic mass, which is 14. 3 times 14 gives 42. Hydrogens, how many have we got inside the bracket? We've got 4 multiplied by the number outside the bracket, which is 3. 4 times 3 gives us 12. 12 times 1 gives us a total of 12 grams. Phosphorus, how many have we got in the formula? We've only got 1. 1 times 31 gives 31. And how many oxygens have we got? We've got 4 times by the relative atomic mass, which is 16, which gives us a total of 64. When we add those up, we get a total GFM of 149. Now we're going to work out the percentage composition of nitrogen, which is an essential element. The total mass we calculated on the left hand side of nitrogen was 42. Put it over the GFM 149 and multiply by 100, and that gives us a percentage of 28.2%. Phosphorus, we do 31 over 149 times by 100 gives us a percentage of 20.8. When I add these percentages up, that gives me a total percentage of essential elements in this fertiliser as 49%. So what we can see from calculating the percentage composition of NP or K in each of the fertilisers is that potassium phosphate has the most essential elements and ammonium nitrate has the least essential elements for percentage composition. This past paper question is from the National 5, 2017, multiple choice 17. Which of the following is not an essential element for healthy plant growth? Remember, the elements that we're looking for are N, P and K. So the correct answer to this is oxygen, as oxygen is not an essential element for healthy plant growth. This past paper question is from the National 5, 2019, multiple choice question 10. Ammonium nitrate, NH4, NO3, has a gram formula mass of 80. The percentage by mass of nitrogen in ammonium nitrate is equal to. Now, I always like to show all of my working, even though the gram formula mass has been given in the question. How many nitrogens do I have in the formula that's been given? I have 2. 2 times 14 equals 28. How many hydrogens do I have? I have 4. And the relative atomic mass is 1. 4 times 1 equals 4. Oxygen, I have 3 in the formula, times by the relative atomic mass, which is 16. 3 times 16 equals 48. When I add those up, I get a gram formula mass of 80 grams. The question wants us to work out the percentage composition of nitrogen in the compounds. The total mass of nitrogen that we've calculated by showing our working for our GFM is 28 over the GFM, which is 80, multiplied by 100. So the correct answer to this question is multiple choice answer B. This past paper questions from the National 5, 2018, multiple choice 20. Which of the following salts would not be used as a fertiliser? So remember that they have to contain the elements N, P and K, and they must also be soluble. So what I would do with this is I would actually write out the molecular formula for each of the salts. And what we can see is the only one that doesn't contain the elements N, P or K is sodium chloride, multiple choice answer C.